In this video, we're going to talk about MQTT. It stands for Message Queuing Telemetry Transport. It's a lightweight, publish-subscribe based messaging protocol designed for low bandwidth, high latency, unreliable networks. It was developed by IBM in 1999 for machine-to-machine communication, and it's designed for IoT devices, so you can have all of these slow devices sitting around your industrial setup where you have a bunch of sensors that needs a way to send out their data, and you have a bunch of subscribers that need to subscribe to all this data and figure out what's going on everywhere. So whenever your industrial setup, you'll have a bunch of information lying around and you want to send that to a common place. Now you might want to show it at multiple places, but you'll have that central broker that's going to collect all of the information from all the publishers and send it out to all of the subscribers. That's the idea of MQTT, of course, with the notion that this is built for low bandwidth. It's built for bad connections, basically. So if we take a look at the history of it, this was originally developed as a way to connect oil pipeline sensors over satellite networks. Which, if you go back to the late 90s, you'll realize how slow those connections were and how unreliable they were. This was later released as an open standard in 2010, and today it's maintained by the Eclipse Foundation. It's widely used in the Internet of Things and IoT, and that's generally what you want to use it for. So if you're watching this video and you're thinking, what am I going to use this for? Well, IoT. That's the ideal use case for it, really. Because you have this low overhead and you have real-time communication and all of that in it. So some of these basic concepts and the terminology of MQTT that you need to understand is that you have this publish-subscribe model. MQTT uses that publish-subscribe model where publishers send messages to a broker and subscriber receive messages from a broker based on topics that they've subscribed to. And you can really see that as a differentiating factor between the way that HTTP and MQTT is set up. But I'm getting ahead of myself. Let's just define these concepts. We have topics. So whenever you publish something, you'll publish something on a topic. So you can really see this like a news website, right? So if I'm going to publish sports scores, I'm going to put that under the topic of sports scores, because the people who don't care about sports, they're not going to subscribe to that, but they might still subscribe to news regarding the financial sector or some other topic, right? So we have topics like that in MQTT. Then we have quality of service, and we're going to dive a little bit into that later on. But generally we have 3 levels of quality of service. Then we have, of course, the publishers, the subscribers, and a client is a common term for something that's either a publisher, a subscriber, or both. And then we have a broker, which is the central unit that connects everything. Then we have retained messages, which is messages that are saved by the broker and delivered to new subscribers when they subscribe to a topic. So it's generally used in industrial automation, in smart homes and buildings, healthcare, energy, utilities, transportation, agriculture, stuff like that, where you have a lot of sensors with a lot of distance between them, and you need to send data over low bandwidth at bad connections, all of that. You'll probably get that point. So let's talk about the client-server model, because the client-server model is different in MQTT from what you know in HTTP. So if you've worked with HTTP, you're used to working with a request-response paradigm that holds that has no state. So generally, when you make an HTTP request, you ask for some information as a request, and then you get a response back. And then everyone forgets about what happens. If you want to follow up with a new request, that's up to you, and you can build an application that generates a new request from whatever it just learned. But HTTP itself doesn't care. The connection is over. Now you can do certain things with headers to allow the connection to stay alive, to make the next connection faster and stuff like that. But generally, HTTP is purpose built and really good for websites. That's really what it's for, right? Even if you want to update your website by pushing new files onto the server that hosts your website, you're going to use FTP. And there are different protocols, and one of those protocols would be MQTT, which also builds on top of the TCP stack. So that means that when we talk about how MQTT is really reliant, and you know that your data is always going to get out there, depending on the quality of service you selected, of course, that's because the TCP protocol is responsible for the handshake. So TCP is going to let you know that, yes, I received the data. So everyone knows that the data arrived in the state that it's supposed to. But it is different in that there is actually a state. Whenever you connect a client to a broker in MQTT, that connection stays open in a socket connection, and you have this ongoing data transmission. Now, you might not want to send data continuously, and so MQTT has these stay alive messages where it just sends a really short message forth and back just to show you that that it's still alive. And what it's going to do is it's just going to send a ping request, or PING REQ, and then it's going to get a ping response, PING RESP. So just a simple string back and forth, just to say, hey, are you still there? Yep, I'm still here. Okay, great. Because if you have a sensor and you're using this to send sensor information, then you don't want to just keep on sending the same sensor information. Generally in MQTT, you'll only want to send a new sensor value whenever the sensor value has actually changed. Once again, this is to avoid the scenario where you're just pushing the same data over and over and over again. You don't want that in a bad connection. If you have low bandwidth, you'll want to send as little data as possible. And that also means that where, in HTTP, you have these key value pairs in your headers, you generally don't have that. In MQTT, you just have a single really short header that tells you that this is MQTT, and that's it. So you have an open connection, and when you have that open connection, that also means that the client needs to have its own client ID whenever you connect it to the broker. Now, that client ID needs to be something tangible that you can attach again, because even though we have this open socket connection, at one point that socket connection could break. Something could go wrong and you might need to reconnect. And it's important to tell the server or the broker that this client is the same client that connected before. And you do that with the client ID. Now in computers, you might be used to some setup where you have IP addresses that are handled by a DHCP and stuff like that. But you can't really treat it like that, and you shouldn't be relying on IP addresses as a client ID either, because IP addresses have a tendency to change. So if you're doing this on a network that has a DHCP and you unplug your device and plug it back in, or remove it from Wi-Fi and add it to Wi-Fi again, which you would do if you just reboot the device, then there's a really good chance that you'll end up with a different IP address than what you had before. So you can use something like a MAC address or something similar, or you can make a programmatic setup where you have a broker that will actually hand out an ID to you. But generally, the best idea is actually to use a MAC address. They're long enough and unique enough that you know that you'll never run into the same one twice. But if you can't do that for whatever reason, then you can create a piece of software that keeps track of these client IDs and hands out new client IDs if you need to. But if you do that, remember that the purpose of the client ID, or one of the primary purposes of the client ID, is to make reconnection of the same publisher possible. So it shouldn't be something that always hands out an ID. We do have different message types. So we have these three types of messages. We have publish, subscribe, and we have unsubscribe. And publish is going to be MQTT client that sends a publish message to the broker to publish the message on a specific topic. And we have subscribe, which is an MQTT client that sends a subscribe message to a broker to subscribe to messages on some specific topic. And then you have unsubscribe, which is an MQTT client that sends an unsubscribe message to the broker to unsubscribe from messages on a specific topic. And then it's up to the broker to remember who's subscribed and unsubscribed on a specific topic. And whenever someone publishes something, it's sent out to the current subscribers. And that's the general purpose of that broker, right? So when you're building a broker, you can decide whether things should run in real time and keep everything in memory, or if you want to store stuff in a database. Generally, personally, I'm a fan of logging things. So whenever there is a change, a new message or whatever, I would want to just store that so that you can go back and take a look later on to see what was the history of things, even if no subscribers ever got the message. And you can, of course, use some hybrid of this where the database is then loaded in case you have to reboot the broker at some point. So there's, of course, some security concerns with MQTT. It can itself pose some security risks because it generally uses unencrypted communication. And so actually, before we get into that, let me just mention one thing. Today, it's really popular to use REST with MQTT, or at least to use JSON as a serializable, human-readable data format that takes up as little space as possible, but is understandable by so many services. It just makes sense to use JSON as your data format in MQTT. But this is not something that's defined by the protocol. And since the purpose of MQTT is to send as little data as possible, it might make sense to come up with your own data set. And in some instances, like for instance, some networks, like if you're working with a Sigfox network, then you'll only have 8 hexadecimal values to send 15 times per day. Then you'll have to figure out a way to convert your data into those hexadecimal values, and that's completely okay. That's part of the MQTT standard, that you can work with serializable data in that way. Anyway, let's get back to these security concerns with MQTT, because you generally have these unencrypted communications, and you have a potential for unauthorized access to brokers and clients, and you could spoof the client IDs and make someone connect or disconnect. And by the way, if you're reconnecting, you'll have to specify whether you want to remove the old session, or if you want them both to work simultaneously until the takeover has been completed. But we have these MQTT security mechanisms. And first of all, we can use transport layer security, also called TLS, where we use an SSL certificate to make an encrypted connection, just like you know it from HTTPS. We can do that in MQTT. We can, of course, use user authentication, but when we do user authentication, it's usually done with usernames and password in the body of a message, rather than in a header, because we have these minimal headers. And we should use access control, and it's actually good practice to use something like two-factor authentication, where when you have to reboot a device, someone will have to actively just say, okay, that this was actually replaced. This is not someone else who replaced the device. And that is, of course, because we have these open connections. So there are several tools and resources available to work with this, including MQTT Security Working Group, MQTT.fx, Eclipse, PAHO, and things like that. So if you want to get more into the security aspect of it, those would be some great resources. There are, of course, a bunch of different libraries that you could use if you want to implement this. So MQTT is generally not something that you want to implement from the bottom up, just like you wouldn't implement HTTP from the bottom up in your project. You just use the HTTP protocol, and while MQTT is not installed by standard part of like a Node.js or a PHP or something, there are packages that'll let you work with it in PHP, Node, Java, Python, C++, JavaScript, whatever it is. So you can definitely work with this in your programming language of choice. There are pre-written brokers that you can get and you can use. Some of those would be Mosquito, HiveMQ, or EMQX. And when you work with it, of course, it's important, just like with everything else, to read up on the best practices and follow them. So use these high-quality MQTT client libraries. Don't try to write these things yourself. Just try to understand them as best you can and then use them in the way that they were intended. Choose an MQTT broker that meets your system needs of scalability, reliability, security, those kinds of things, and then use the appropriate quality of service. And when we talk about quality of service, I said in the beginning that there are 3 levels of quality of service. So you have quality of service 0, 1, and 2. 0 means at most once delivery. So that means whenever you have a new value on your sensor, if that's what you're tracking, you'll try and send that, and you'll just try once. That way it'll be delivered at most once. Then you have quality of service level 1, so one step above 0, which is called at least once delivery, which means that whenever you send a published message, the broker will send back a poo back message, which just means that, yep, I got it. Don't send it again. And then we have the exactly once delivery, where you send your publication and then you get that pub rec back, and you'll send the pub rel and you'll get a pub comp release. So what that means is you're basically doing a handshake where you're saying, here's the message. Okay, I received it. Okay, I received that you received it. Okay, this transaction is over. So a bunch of extra steps, but these are super short, like 7-letter messages, 6 and 7-letter messages that you're sending back. So it's not a lot of data, but this will ensure that you get the data exactly once. So there's no more guesswork, as in, did the temperature spike or did we just not get that one message? And the MQTT protocol also includes this CONNAC message that the broker sends to the client after the client initiates the connection using a CONNAC message. I also want to just quickly talk about some of these differences between MQTT and HTTP and REST. So, of course, there is the whole communication pattern where MQTT uses this publish-subscribe pattern with open socket connections that have a state and have continuous pinging whereas HTTP just has request response stateless. And that, of course, is the second point, the connection state, right? That MQTT is very stateful, whereas HTTP is stateless. You can do things with sessions and cookies and stuff like that to remember things between calls, but the calls themselves are stateless. Then you have message delivery, where MQTT provides different quality of service levels. HTTP doesn't do that. They just use the handshakes of TCP, end of story. And then you have the whole overhead, where MQTT has a way smaller overhead compared to HTTP due to this lightweight protocol, where, for instance, we have this 8-bit header as the only header, instead of key value pairs in HTTP. And then we have real-time updates, which is kind of funny because this means that MQTT will generally be faster than HTTP, but HTTP is just built for larger loads, and MQTT is built for smaller loads that are going to work faster and basically in real time. So, if we were to sum up the key points of MQTT, MQTT stands for Messaging Queue Telemetry Transport. It's a lightweight, publish-subscribe based messaging protocol designed for low bandwidth, high latency, unreliable networks that works with open socket connections between clients and a broker. Everyone can publish content to a topic, and subscribers will be notified when new data is published on a topic. Publishers will generally only send out information whenever a sensor value has changed, and in between that there will be pinging messages back and forth. It has a lot of similarities to HTTP, given that it has the same level in the OSI model, and it also works on top of TCP, but it also has a bunch of differences. It's really good for IoT and systems where you might have unreliable connections. You have a bunch of ways to work with the connections being unreliable, data not getting out in time, what quality of service that you want, and there are general ways to work with that. So that's the general info and the general things that you'll need to know about MQTT. If you have any questions about it, let me know in the comments, and I'll see you in the next one.